Today, we are going to learn lesson 5.2, Gravity and Satellite. Focus. Answer questions from 1 to 4 by completing the sentences. What is a satellite? A satellite is a body which orbits a body in space. What type of satellite is the moon? The moon is a satellite of the Earth. What type of satellite is a communications satellite? A communication satellite is a satellite. What force of attraction exists between the Earth and the Moon? The Moon and Earth are attracted towards each other by the force of gravity. So, a satellite is a body which orbits another body in space. Another body in space. And the Moon is a natural satellite. And a communication satellite is a communication satellite is a communicating satellite. Well, that's the obvious thing. What force of attraction exists between the Earth and the Moon? The Moon and the Earth are attracted towards each other by the force of gravity. Question 5. Look at the diagram. Which force line, A or B, shows the force of gravity that the Earth exerts on the Moon? So it is A, pulling the Moon towards the Earth. And why is A bigger arrow than B? It is because the gravity that the Earth exerts towards the Moon is stronger than the force of gravity that the Moon exerts on Earth. Question 6. What is a natural satellite? A natural satellite is a satellite that is not an artificial satellite. And humans have not made that satellite. Like people have not made the Moon. And the example is the Moon. The Moon is a natural satellite of the Earth. Question 7. What is an artificial satellite? Give an example. So an artificial satellite is a satellite that humans have built. An example of that is the ISS, or the International Space Station. Question 8. Complete the diagram of an artificial satellite orbiting the Earth. Draw a force arrow to represent the force of gravity between the Earth and the satellite. Draw a force arrow to represent the force of gravity between the satellite and the Earth. So, the Earth exerts a larger amount of gravity than the satellite. So this arrow needs to be bigger than the other arrow. Like this. Explain why you drew one arrow bigger than the other. Well, just what I said. The Earth has more mass than the satellite. So it exerts more gravity to the satellite. Wait a minute. These things are reversed. There we go. So the Earth pulls the satellite towards the Earth stronger than the satellite pulls the Earth towards the satellite. Challenge. Over 37,600 kilometers an hour, an object will leave Earth's gravity. At 27,200 kilometers per hour, it will go into orbit. But slower than that, it will fall back to Earth. What type of satellite is shown in the diagram? So these three satellites they are artificial satellites made by humans. What launches the satellite into space? So the rockets at the satellite, they help launch the satellite into space by pushing towards the Earth and moving really fast against the Earth to leave Earth's gravity and go into orbit, but not falling back to Earth. Why is it necessary for the satellite to travel at over 37,600 kilometers per hour when it leaves the surface of the Earth? Because satellite is an object that orbits around another object. That's what you see here. In the first question. So if it wants to be a satellite, then it needs to travel really fast at over 37,600 kilometers per hour. And when a satellite travels at 27,200 kilometers per hour, what path does it follow? So imagine this is the Earth. Yeah, that is not like the Earth at all, but pretend this is the Earth. When it travels at 27,200 kilometers per hour, it will go into orbit. So it will circle around the Earth. And this is not a circle if I've ever seen one. But the path it follows is some sort of a circle. Question 14. What force keeps the satellite following this path? So, it is the applied force of the satellite, right? You know, right? It's the applied force of the satellite. Because the satellite applies this force so that it can fly up into the air. What happens to the satellite if its speed drops below 27,200 kilometers per hour? So if it was just slightly slower, like 27,199 kilometers an hour, it will go down slowly. But if it was way slower than that, if its speed was way slower than that, like 0 kilometers per hour, it will just drop straight down into the Earth. So, that's the end of this lesson. Thank you and goodbye.